We're going to check our answers for the Module 3 review pages from your math book on pages 97 through 99. The first page asks you about your vocabulary words that we've talked about in this module. We had the words algorithm, front-end estimation, regroup, compatible numbers, partial sums, and variable. So question number 1. A blank is a letter that represents an unknown quantity. We know when we have an unknown quantity in an equation, we use a letter called a variable to represent that amount. Number 2, a blank is a way of doing something in math. It is a set of steps that, if done correctly, always works. That's an algorithm. We have a lot of different strategies we can use to solve problems, but we can always go back to the standard algorithm to follow that specific set of steps. And when we do it correctly, it will work all the time, no matter what the numbers or the problem are. Number 3, blank are numbers in a problem that are easy to work with mentally. One of those strategies that we can use to come up with other ways besides the standard algorithm to solve is by using compatible numbers or easy numbers to work with. So number 3 is compatible numbers. Number 4, when using blank, you keep the front or leftmost digit and all the other digits become zeros. That's front-end estimation. It's one of those strategies we talked about when we want to just get close to the exact answer. We want to be able to quickly and easily come up with a close answer in our head. We don't need the exact quantity. Number 5, you can blank to add numbers. Add one place value at a time and then add those sums to find the total sum. So that strategy is partial sums. That's when we add one part at a time, then add those sums all together to find our total. And number 6, to blank means to use place value to exchange equal amounts when renaming a number. When we use the standard algorithm, we have to regroup when we have 10 or more in one place value. Remember, you can pause this video or you can rewind to go back and look and correct any mistakes that you've made. This is for you to use to help you. This is your checkpoint to see what, let yourself know, hey, I need to go back and practice this. Okay, let's look at number 7. Number 7 says a company logs the number of minutes employees use on company cell phones. In April, the employees used 2,843 minutes. In May, the employees used 4,923 minutes, which is a good estimate of the number of minutes the employees used in April and May. So the question is asking us for a good estimate of the number of minutes the employees used in April and May. It tells us to estimate. We're not looking for an exact answer. We're looking for something close that we can quickly and easily come up with in our head. So if we use the number of minutes from April, we use an A for April, they used exactly 2,843 minutes. In May, I'll use an M for May. The employees used exactly 4,923 minutes. Remember, it asked us for an estimate, so we don't need an exact number. We just need something that is close. So if I look at the number of minutes in April, 2,843 is really close to 3,000 minutes. The total number of minutes from May, 4,923, that's really close to 5,000 minutes. Those numbers are a lot easier to work with in my head, and I can see that the employees of that company used about 8,000 minutes for the months of April and May. Number 8. An office building sells for $350,000. A house nearby sells for $245,600. How much more money does the office building sell for? The question's asking us, how much more money does the office building sell for? I know the office building sells for $350,000, and we know that the house sells for $245,600. If I were going to model that, I could use a bar diagram. We know the office, I'll use an O for office, sells for $350,000. We know the house sells for $245,600. And we want to know how much more the office building sells for. We're trying to figure out how much more it costs to buy the office than it did the house. This bar diagram shows us we could solve $245,600 plus, we'll use X for how much more money the office building sold for, is equal to the total amount cost for the office of $350,000. That's one way we could set up our equation. But we also know that we can use the relationship between addition and subtraction. And I can solve by taking the total amount of the office building and subtracting the amount of money that it cost for the house that was nearby. And that answer is going to give me the amount more that it cost to buy the office building than the house. I'm going to set this problem up using the standard algorithm. $350,000 is the total amount. I'm taking away the part that it cost to buy the house, $245,600. Change colors so that we can easily see what we're doing here. When I use the standard algorithm, I've made sure all my place values are lined up correctly. And I start in my smallest place value and I work my way to the biggest. So 0 ones minus 0 ones is 0. Now I move to my tens place. 0 minus 0 is 0 again. When I get to my hundreds, I have 0 hundreds and I need to take away 6. I don't have 6 hundreds to take away, so I'm going to regroup. If I look to my thousands place, I don't have anything to regroup, so we're going to have to come all the way over to the 10,000s. I'm going to take one of my 10,000s, that leaves me with 4. And I'll regroup it over to my thousands. I know that it takes 10 thousands to equal that one 10,000 that we regrouped. But that still doesn't help me in my hundreds place value. So now I'm going to take one of those thousands. That leaves me with 9. And I'm going to regroup that 9,000, that 1,000 over to my hundreds. That will give me 10 hundreds to equal that same amount. Let's pause right there for just a moment. The amount that we started with, the amount that the office building sold for was $350,000. I've done some regrouping here. We still have 300,000s. Now I have 4 10,000s, which has a value of 40,000. Have 9 thousands, 10 hundreds, no tens and no ones. I can see if I add all of those parts together, I am coming up with the exact same amount that we started with. No hundreds, tens, or ones. Have 10,000s. I regroup 1. 4 plus 1 is 5, and 3 plus nothing is 3. We can see, even though we've manipulated or changed the units around, we have not changed the value of that office building, which was $350,000. So now let's go back and subtract. We've already subtracted our ones. We've subtracted our tens. We've regrouped to make 10 hundreds minus 6 hundreds. Leaves us with 400. If I go to my thousands, 9,000 minus 5,000 is 4,000. 4 10,000s minus 4 10,000s is 0 10,000s. And in my 100,000s, 300,000 minus 200,000 is 100,000. So our answer is 104,400. Going to erase this really quickly so that we can check our work. So we've just solved how much more money does the office building sell for. We found that the office building sold for $104,400 more than the house. And I can always check my work by taking this amount here, 104,400. That's the amount that we found to be the difference in the two costs. I can add it to the cost of the house, 245,600. If I add those together, I get 0 ones, 0 tens, 10 hundreds, so I'm going to regroup. 1 plus 4 makes 5, and another 5 is 10. I'm regrouping again. 1 plus 0 plus 4 is 5, and 1 plus 2 is 3. So we can see we get to the total amount that it costs for the office building of $350,000. So our answer is correct. The office building sold for $104,400 more than the house. We know our variable X has a value of $104,400. Number 9. A concession stand has $620. They earn $525 selling popcorn and $162 selling drinks. They spend $365 to order more supplies. Write an equation to show how much money the concession stand has now. This says write an equation to show how much money the concession stand has now. So let's go back to our problem and look and see. And it says the concession stand has $620. They earn $525 selling popcorn and $162 selling drinks. If they earn that much money, we know they're adding that to the amount they have. The next sentence says they spend $365 to order more supplies. If they're spending money, they're taking part of their money and using it for something else. So we're taking that away. It says write an equation to show how much money the concession stand has now. The amount of money that the concession stand has, they started with $620. They added or earned $525 from popcorn. They earned or added another $162 from drinks. And then they spent $365. So we're going to take that amount away. It just tells us to write the equation to show how much money the concession stand has now. But we could go ahead and solve that. 620 plus 525 plus 162. I'm going to line all three of those up and add them together. 0 plus 5 plus 2 is 7. 2 plus 2 is 4. And 6 makes 10. I'm regrouping that 1. 1 plus 6 plus 5 plus 1. I can see 5 and 1 make a 6. That's a double. 6 plus 6 is 12. Plus 1 more is 13. So the amount of money that they had before their supplies was $1,307. Then we know they spent $365 to buy more supplies. So we're going to take that amount away. 7 minus 5 is 2. Move to my tens place. 0 minus 6. If I have 0, I cannot take 6 away. I'm going to take one of my hundreds. That leaves me with 2. 100 has the same value as 10 tens. 10 minus 6 is 4. Now I'm moving to my hundreds. I have 2, and I need to take 3 away. If I have 2, I can't take 3 away, but I can use some number sense and see that what I have left in this problem is 12 minus 3, and I can go ahead and I can subtract 12, take away 3. That leaves me with 9. So if we wanted to know how much money the concession stand has now, we found that M, or the amount that the concession stand has now, is $942. Number 10. An elementary school is collecting box tops. The table shows how many box top each grade has collected. First grade collected 2,475 box tops. Second grade collected 3,256. Third grade collected 1,982. And fourth grade collected 4,034. It says, which two grades combined have collected about 5,000 box tops? Explain how you found your answer. Remember, it says about 5,000. We're looking for an estimate, something easy to work with. There's a couple different options that we could go with since it tells us about and we're estimating. 2,475 is a little more than 2,000. 3,256 is just a little bit more than 3,000. 1,982 is almost 2,000. And 4,034 is almost 4,000, just a little bit more. A little bit of number sense. I can see by looking at these numbers, this is about 3,000. Third grade collected about 2,000. And I know that 3,000 and 2,000 together make 5,000. So I would say just by looking quickly that we can see second and third grade together collected about 5,000 box tops. We could justify some other answers. If we rounded, 2,475 would round back to 2,000. And 3,256 would round back to 3,000 if we rounded to the nearest thousand. So we could say those two collected about 5,000 box tops. We could also use front end estimation. 2,000 and 3,000 make 5,000. We could use front end estimation to show 1,000 and 4,000 also make 5,000. And that's why it's important here that we explain how we found our answer, because you could justify different combinations of grades to be about 5,000. That's why once again, it's very important that you explain your reasoning, because if you can explain it, then you can justify more than one combination of grades. Number 11. A bakery sold 1,353 muffins on Friday and 2,231 muffins on Saturday. How many muffins did the bakery sell? We're looking for how many muffins did the bakery sell. So we know on Friday the bakery sold 1,353 muffins. And 2,231 muffins on Saturday. 2,231 muffins on Saturday. We want to know how many muffins the bakery sold. So the number of muffins the bakery sold will be the amount they sold Friday plus the amount they sold Saturday. 1,353 plus 2,231. I'm going to line these up and use the standard algorithm to add. 1,353 plus 2,231. I've made sure all my place values are lined up correctly. Starting in my smallest place value, 3 plus 1 is 4, 5 plus 3 is 8, 3 plus 2 is 5, and 1 plus 2 is 3. So the bakery sold 3,584 muffins. Number 12 says find 39,491 plus 56,356. It does not tell us what strategy we have to use. I'm going to use the standard algorithm just as practice. 39,491 plus 56,356. 1 plus 6 is 7. 9 plus 5 is 14. I'm going to regroup my 10. 3 and 1 make 4. That's a double. 4 and 4 is 8. Then 9 plus 6 is 15. Regroup that 1. 3 plus 5 plus 1 is 9. So my answer is 95,847. Next, we're subtracting to find 6,763 minus 5,498. Again, I'm using the standard algorithm. 6,763 minus 5,498. Start in my smallest place value. I have 3. I need to take 8 away. I don't have enough. So I'm going to come over. I'm going to take a 10 and regroup it to my ones. 10 ones plus 3 ones makes 13. 13 minus 8 is 5. Then in my 10s I have 5 minus 9. If I only have 5, I can't give 9 away. So I'm going to regroup. That leaves me with 600s. Takes 10 tens to equal 100, so that gives me 15. 10 plus the 5 I already had is 15. 15 minus 9 equals 6. 600s minus 400s is 200s. And 6,000 minus 5,000 is 1,000. So my answer is 1,265. Next, we're subtracting again. 71,395 minus 6,627. 71,395 minus 6,627. I made sure to line my place values up. I have 5 ones. I need to take 7 away. I don't have enough, so I'll have to regroup. That leaves me with 8 tens. Now I have 15 ones. 15 minus 7 is 8. 8 minus 2 is 6. 3 minus 6. I don't have enough hundreds, so I'm going to have to regroup one of my thousands. That leaves me with no thousands. And 13 hundreds. 13 minus 6 is 7. 0 minus 6. I can't do that, but once again, I can use a little bit of number sense and see that I've got 70 minus 6. I need to go 6 back from 70. That's going to be 64. My answer is 64,768. Number 15, we're adding. I've got 10,252. I'm adding 1,298. Start in my ones place. 2 plus 8 is 10. I'm going to regroup 1. 1 and 9 make 10, and 5 more is 15. I'm going to regroup a 1. 2 plus 2 plus 1 is 5. And 10 plus 1 is 11. My answer is 11,550. Number 16. A theater has 1,485 tickets to sell. They sell 691 tickets for main floor seats and 478 tickets for balcony seats. There are 184 tickets still available for balcony seats. How many tickets are still available for main floor seats? Explain how you found your answer. So the question wants to know, how many tickets are still available for main floor seats? We need to go back and look very carefully at the information they gave us. It says the total number of tickets to sell, I'll use a T for that, is 1,485. They sell 691 tickets for main floor seats. Main floor is 691. And 478 tickets for balcony seats. So together, these are the number of tickets that are sold. It tells us there are 184 tickets still available for balcony seats. So those are available balcony seats. I'm going to put a little B down there just so I remember that. That's 184. How many tickets are still available for main floor seats? And we're looking for how many tickets are still available for the main floor. So I'm looking for the main floor availability. That's what we don't know. So if I know the total amount of tickets to sell is 1,485. There have already been 691 tickets sold, and 478 tickets sold from the balcony. If I subtract those, that's going to give me the number of tickets that are still available. 1,485 minus 691, my total minus the main floor seats available. 5 minus 1 is 4. 8 minus 9, I'm going to have to regroup. 18 minus 9 is 9. I can't do 3 minus 6, but I can see this is 13 left. 13 minus 6 is 7. So that's 794. Then I can take away the 478 tickets that have been sold for the balcony. I'm going to have to regroup here. 14 minus 8 is 6. 8 minus 7 is 1. And 7 minus 4 is 3. All right, so 316 tickets are total, minus the main floor seats that are sold, minus the balcony seats that are sold. So there's 316 tickets left. Of those 316 tickets that are left, 184 of those belong to the balcony. So I need to subtract those to figure out how many are left for the main floor. 6 minus 4 is 2. Then I have 1 minus 8. I'll have to regroup. 11 minus 8 is 3, and 2 minus 1 is 1. So there are not $132. There are 132 seats available on the main floor. There's several different ways we could have solved that, but to solve, we took the total number of tickets. We subtracted the number of tickets that had already been sold for the main floor. Then we subtracted the number of tickets that had already been sold for the balcony. That gave us a remainder of 316 tickets or seats left to sell. So we took that 316 tickets that were still available, and we took away the 184 that were still available in the balcony, and that left us with 132 main floor seats still available. Number 17. Chandra wins 2,184 tickets at the arcade. Mavis wins 1,135 fewer tickets than Chandra. How many tickets does Mavis win? I'm looking for how many tickets Mavis wins. I know the total amount that Chandra wins was 2,184. We know Mavis wins 1,135 fewer. So since it's fewer, that tells me I'm going to need to subtract to find the difference. I have 4. I need to take 5 away. I can't do that, so I'll regroup. 14 minus 5 is 9. 7 minus 3 is 4. 1 minus 1 is 0. And 2 minus 1 is 1. So Mavis wins 1,049 tickets. Number 18. A summer camp has an art program and a music program. The art program has 1,053 more students than the music program. If the music program has 2,118 students, how many students are in the art program? I'm trying to find out how many students are in the art program. So I know that the art program has 1,053 more students than the music program. And we know that the music program has 2,118 students. This represents the music program. And it tells us that there's that many and 1,053 more art students than music students. I can combine those to figure out the total number of students that there are in the art program. So I'll need to add 2,118 plus 1,053. Since I'm adding, it does not matter what order I write my add-ins. 8 plus 3 is 11. To regroup my 10, 1 plus 5 plus 1 is 7. 1 plus 0 is 1. And 2 plus 1 is 3. So there are 3,171 students in the art program. And number 19, there are 551 cars parked in an airport parking garage. The first level has 128 empty spaces. The second level has 294 empty spaces. The third level has 302 empty spaces. How many spaces are in the parking garage? Explain how you found your answer. I'm looking for how many spaces are in the parking garage. So it tells us there are 551 cars parked in an airport parking garage. The first level has 128 empty spaces. The second level has 294 empty spaces. And the third level has 302 empty spaces. How many spaces are in the parking garage? So the number of cars in the garage are 551. There are also 128 spaces in the first level that are empty. In the second level, there are 294 spaces that are empty. And in the third level, there are 302 spaces that are empty. To find out how many spaces are in the parking garage, we're going to add the total number of cars parked there, plus all the empty spaces. I'm going to add all of these at the same time. 551 plus 128 plus 294 plus 302. I can see that this 8 and 2 together make a 10, and 1 and 4 make 5, so that total is going to be 15. I'm regrouping my 1. My 1 and 9 make a 10 together. Another 5 is 15, and 2 more is 17. I'm writing down my 7. Regrouping the 1. 3 and 2 make 5. Another 5 is 10. Plus 1 is 11, and another 1 is 12. So in the parking garage, there are 1,275 spaces. I found my answer by adding the total number of cars that were parked in the parking garage, plus the empty spaces on the first level, the empty spaces on the second level, and the empty spaces on the third level. And that gave me my total of 1,275 spaces in the parking garage. If you watched all of this video, I want you to put a big smiley face at the top of your paper. Take a deep breath and remember to have a fantastic day. I'll see you guys tomorrow.